Hello, everyone, and welcome to our systems analysis and design final project. We did a room reservation redesign of the Georgia Tech system. We're here with Rafid, Catherine, Amy, Varun, and myself, Robert. And moving into the business problem, we looked at the Georgia Tech reservation system. Like I said, it's very inefficient, leads to a fragmented system integration, limited user interface capabilities, and a lack of real-time updates. This causes delays, booking errors, and overall poor user experience and headaches for users on the student and faculty side.
Moving into the sources, we have our four interviews. We have David Alberti, the facility manager of Scheller, and then we have three student users, Ian, who's an intermediate student user, Raj, who's a novice student user, and Anu Lal, who's an experienced student user.
So moving on to the as-is process.
First, with our context diagram, we decided to break up and explain how reservations were viewed and approved. And then next, our first relevant persona we created was Student Buzz. Their goal is to reserve a space, receive timely notifications on approval status and fee updates, as well as view accurate and up-to-date information on rooms. Our next relevant persona is Administrator Buzz, who is an employee of the Institute that it has the goal of approving a space in the system, receiving notifications when requests are submitted, and quickly and accurately making updates on that admin side.
As you guys can see, the roles that we have in hand are like the facility manager, who has to approve events but struggle to do that, especially since holidays and exceptions aren't automatically entered. We also have the student organization members who really value that real-time notification, but don't quite have that right now. And moving on to our other users, the students who just might want to reserve on the daily basis for their own personal use, along with faculty who want to book things for their own events and for internal and external events.
So moving on to process one. So here's a brief summary of our narrative description. To start with, the user logs in through Buzzport and initiates a reservation request. Then the user selects a predefined reservation template. And if the criteria is met, the user can add event information such as building, date, time, and attendance. Then the EMS shows available rooms and the user selects one and submits a request. Then the admin team checks for conflicts such as class schedules, holidays, etc. If approved, confirmation is sent, and if fees apply, payment is processed. And once access is granted, it's typically synced to the user's bus card. And if there is a conflict, the approval is denied, and so the system notifies the user through email and may get a custom note by the admin, and users then can revise and submit another request. And the overall goal of the EMS system is to just streamline space usage, reduce admin load, and improve the user experience.
So moving on to the written use case, it illustrates the flows and exceptions of the reservation process. Various parties have an interest, such as the building admin, maintenance, student event organizers, and OIT. However, the primary user story focuses on the need for students and club members to reserve rooms through the EMS to guarantee their space. A user must have a valid GT login, and they initiate the process when they choose the reservation template to indicate the building that they're reserving. In the worst case, there are no approvals and the system sends an automated message of failure. In the best case, the room is booked, approved quickly, and charged if there are any fees. In this best case scenario, the organizer selects a date and time for reservation and chooses a room from the list of available rooms and specifies the number of attendees. From there, the admin takes over. After the booking is logged in the system, the admin periodically checks the system and approves the room. The system confirms this to the user and calculates a fee quote. The organizer then pays the fees and is free to use the room. However, there are some exceptions to this best case scenario. The first exception is that if no rooms are available, there are no results and the user has to search again for a different time, which takes a lot of time and it's a tedious process. If the admin does not approve because of a conflict, an automated message is sent and the admin can add a manual explanation as well. If there is no fee, the user has access to the system immediately. However, if the user cannot pay the fee, the booking is canceled.
So moving to our as-is process diagram, very similar to what's been written in our use case, but using this type of modeling shows some key flaws of the as-is system. So moving on to flaw number one, if you look at the first looping structure that crosses the first and second swim lane, the user has to select a date to see which rooms are available. And if there are no rooms available, then the user has to select another date, repeating the same process over and over again until the user finds an available reservation space. And this process will go significantly faster if the user could just select a range of dates instead of one, or have the option to have a calendar view seeing an available reservation dates of certain rooms. And as for flaw number two, if you look at the third swim lane looping structure, the admin does not know when a room reservation request has been submitted. So the admin checks the system multiple times per day to see whether someone has submitted a request due to the lack of real-time notifications. And this contributes to a significant loss of time on the admin's end. And as for flaw number three, if you look at the final third of the process diagram, even after a user gets approval for a reservation space, the individual may still be uncertain if he or she could use the room or not. And this is because the room being reserved may require a fee to be paid. However, in some cases, you may be notified about the fee sometime after the room has been approved. So this lack of transparency can lead to poor planning, since the room has to be canceled if one cannot pay the required amount and the individual has to find a replacement room. So these are some key flaws of the as-is system. Now we can move on to the requirements for the 2B system.
For the prioritized list of user stories, we use the must have, should have, could have tiers from class. Must have being it's critical for the system. Should have means it's not critical, but it will drastically lower time spent in the system. And could have would improve user experience, but users could live without it. And on the student side, the must-haves focused on improving mobile access to the system for students that try to reserve rooms on their mobile devices on the go, and fee transparency for student organizations so they can stick to their strict budgets and know how much the space will cost up front. And the others focus on more a notification system for students to know when rooms opened up, and a calendar view that would just make the user experience better and make it easier to see what rooms are open when. And on the faculty side, the must-haves were a notification system for when room requests were submitted, and that reduces a lot of the labor instead of the facility manager having to passively check um, when tickets are submitted, and an integration of the calendar from Banner, like institute holidays and classes. So the facility manager does not have to double check across many different systems. And the other one we had is a could have, which is just a portal for uh, user feedback on the system and the rooms being reserved themselves.
And similarly to what we previously said for the relevant personas, student buzz is largely the same, but they will no longer have to wait for time to make reservations, since they don't have to constantly refresh to see new slots, and they will no longer have to question if they have to be charged for a reservation space. And for the administrator buzz, largely the same persona, but they will not have to manually approve room reservations that should already be inputted from Banner, and and they will be able to see new reservation slots as they appear. And this leads into our functional requirements. The four must-haves that we have largely relate to reducing inefficiencies. The first one is that the system will notify the system administrator through text or email when a reservation has been made, which is very similar to the functional requirement number 3, relating for students, that can have a mobile interface for them to reserve spots as well. And for functional requirement 2, the 2B system shall automatically migrate institute holidays and schedules of classes from Banner to avoid booking conflicts. And the rest of them are for the students. The 2B system shall give the upfront cost of the reservation space that is being booked. And a should have that we have is the 2B system shall have a broader calendar view of availability for locations to stop clicking through each day one by one. And the 2B system shall allow student users to opt in for notifications through text or email when a new reservation slot has been opened for a certain location.
Next, the non-functional requirements are detailed on the screen and primarily focus around being able to handle scalability, security, different types of systems, consistent availability, as well as a reliable system performance.
Moving on to the 2B system.
There are a couple changes to the written use case and the narrative flow. As in the previous system, if no rooms are available, the user will have to choose a different time, but that likelihood decreases with the calendar view. Um, in the beginning of the process, the user now looks through a calendar view that highlights days with more availability. They'll also see fees before they book and only pay after use. And finally, the admin is notified through their mobile device of new reservations, reducing the time that's spent in the system. There also are some new changes to the exceptions. If the user is shown fees during their booking and cannot pay, the process ends there. If there's no fee, the user is automatically guaranteed access. And finally, if the organizer cancels their booking, their invoice is deleted, late fees are assessed, and the system notifies users who are opted in of a new room being available.
So moving on to our 2B process diagram. So our 2B process diagram is somewhat similar to our as-is process diagram with some key differences. So as for key difference one, previously mentioned before in our new written use case, the user can now select a range of date and time instead of one, significantly decreasing the time it takes to find available space. And now the system generates an estimate of the room if payment is required before the approval process. And if the user can pay the fee, then he or she is able to enter the billing information. And then the room reservation request is submitted and an invoice is generated. As for key difference number two, the admin has no longer to check the system multiple times to see whether a reservation request has been submitted. This is due to the fact that the 2B system has real-time notifications informing the admin that the request has actually been submitted. And as for key difference number three, if a user cancels a room, then he or she is not charged, but late fees may apply. If a room booking is canceled, individuals who have opted in for notifications about that specific space's availability will be alerted about the cancellation. And now we can move on to prototype organizer reservation processes.
So the first step in our prototype is to log into the reservation system using the GTID and the SSO. And then the next step after that is to choose the reservation template. And that specifies the type of booking and what building it's being booked in. And then the step after that is now a new step, which is to look through the calendar availability, which is a heat map that shows which days have more availability for a certain reservation template. And then moving on to step four, after they've chosen their room, they can specify attendees, set up things like AV and things that might lead to fees. And if there are fees that are incurred, the system calculates it and notifies the fees ahead of time, and they only have to pay when they use the room. So moving on to the administrator side, the newest change that we made is that the administrator receives mobile notifications, which specify the room, the date, and the time of these reservations. And as soon as they receive this notification, they can go into the portal and see if there are any conflicts. And the way they can check these conflicts are against the calendar, which is shown on the next slide. And this calendar shows that the classes are imported from the banner system, so there's no need for the admin to check between multiple systems manually and see if there are any conflicts. So now to wrap it up, looking at the functional requirements that we specified at first and how our design meets them. So the first thing was that we wanted the system administrator to be notified when a reservation be made, and we build that in via the SMS text notifications. We wanted the new system to automatically migrate holidays and classes from Banner, and we show the migration in the system in the calendar view. The 2B system needed to be optimized for mobile interfaces, and we did that with the calendar view, and also we'll test our interfaces across multiple devices. The 2B system shall give the upfront cost of reservations, and the new system calculates fees and shows a breakdown as the user books the room. Finally, we have the calendar heat map view, which satisfies our need for a calendar view availability. And then we also built in an option for the student users to opt in for notifications, and we saw when somebody cancels a request, they are sent a notification. Thank you for your time.